today's talk is going to look at a very specific subject around in the quality assurance and testing space. It is often referred to as a non-functional testing discipline, and that's performance testing. The whole idea of this presentation is to really look at why deconstructing the subject matter. For a lot of people, performance testing is a complex subject and seen as highly technical, and then probably not wrong, but it is not as complicated as one would think. And I believe we need to drive better adoption of this discipline across organization. We are soon going to go through the shopping season, and all those online websites need to be performing. And if they have a very good performance testing practice in place, they would be less stressed about that day where people are all logging in, like your Cyber Monday sales and things like that. And there will be less of this concept of queues, and maybe they would be able to make more money. So that's one of the many things that I've noticed. There's a definite gap in the market in understanding that discipline. So today we would like to really look at why does performance matter, the basics of performance testing from a very simplistic lens. So we would look at the why, the what, the when, and how as well. And I would like to give you a little bit of a practical roadmap as well. So it really sets the scene, and hopefully at the end of this, you will have a better appetite for this. My hope is that you will be willing to have more conversation in your organization around this subject, and be more willing to even introduce some of those disciplines in your organization where relevant. All right, so let's just get into it. The why. So why does performance matter? The big thing, if I can put it like that, is performance testing on its own. We talk about performance here because I refer to performance engineering and performance testing. But the common word in that subject is performance. Why does it matter? First and foremost, it's around proactively managing the risk of an organization, your reputational risk, your legal risk, your commercial risk, making sure that, if I put it in simple terms, you don't have a broken platform when you go live. We talk about software specifically when we talk about this subject. So everything I'm talking about is in the IT world, obviously. So we are talking about the software specifically here, and all the engine that works with the software to get it working. So how do we make sure that we don't have a system in production that is broken, that suddenly goes down, or suddenly is unable to process specific transactions? And that obviously result in a cost value. And that's what we talk about. So performance matter for those reasons. We want to make sure that people have the right experience when they log into an app, to a mobile app, or to a web page or a shopping page. This is an example. They need to have the right experience where loading a page doesn't take more than 5 seconds. In actual fact, the next slide will show you how we live in a competitive world where the 1 second delay people will just lose interest. That's how fast the world is going nowadays. So every delay, every second delay causes you to lose customers as well. So it's around making sure that you have the right experience, the right response times on your pages, for instance, and that it loads correctly. And there are lots of research out there that talks about it, that if a page takes more than 3 seconds, there's a big chance that the users will not return it, rather abandon, and they'll go elsewhere. There's a direct impact on your revenue margin, on your profitability of your organization. You may have the best website in the world, and then the day that you launch, all of a sudden, only 20 people can log in and check out at the same time. And you've got 200 people on the platform, but only 20 people can check out at the same time. So how does that translate? It's very much, a lot of people will give up on the basket and change, or some people will keep clicking the whole day. But it depends how good of a brand your organization have as well. to have that type of wait times that people are willing to endure. So there's also around availability. Performance matters because we live in a world where we are global. We are looking at systems, websites and mobile apps that needs to be available, not just, let's say right now in South Africa, it mustn't just be available during the South African time. We want that website to be available 24/7 so that people across the globe can access your website or your software. And you also have to factor in from an availability perspective that if you are running, let's say, a shopping site, again, as an example, nowadays people use multiple digital channels. So you have to assume that your system must work on an Android phone, on a Apple phone, on the different types of laptops, different types of phones, different type of operating systems. So availability really matter, and you need to check performance across all these different systems, all these different channels. And a lot of people forget about that. Scalability, as your system grow, you need to make sure that your infrastructure scales. People think that they can just throw money at the problem by just buying more infrastructure, but that's not always the answer. So you want to find a way that, you build robustness into your system that allows it to grow without you having to spend millions on constantly increasing infrastructure. Or if you do increase infrastructure, it needs to be done in an efficient way. And the last 2 points on this slide as to why it matters is disaster planning. So we have to be in a position where, as part of performance, if tomorrow you are under attack and a cyber attack, does your system hold the fort, or does it just break like that at the first cyber attack? So how well have you tested the system to make sure that it can sustain 1,000 bots trying to access the system and break down the system at the same time? Have you tested that, for instance? And we live in a world where this exists, right? So I'm not talking about something in theory. So are you able to sustain those type of attacks? So that's part of the disaster planning, but obviously there's way more about disaster planning. There's a whole business continuity planning, and performance is definitely one of the subjects as part of any good business continuity plan. And last but not least is your data analytics. So you want to make sure that people are able to understand your system. There's good monitoring in place. You are able to use these analytics to get better decisions. So if you have a good performance system in place, you will be able to even check your analytics and your performance analytics and drive better decision making to get better revenue or better output from your system. And that's a really nice picture that talks to business. It's around this world that we live in, around continuous customer experience and the fact that we are constantly expected to drive continuous improvement. We talked about it. It's a world that is hyper competitive, global. The market is such that a person will just discover the system, consider it, check whether you're living up to the promises. If you're not, they will just move. And they will purchase and use the products, but they're continuously evaluating all the different systems out there on the market. So you must bear in mind that that this is the type of world we live in, where there's a lot of options out there, and people will jump from your platform if you don't have the right level of customer experience. And that may not have been the case in the past. So the question is, how do you introduce performance into your organization? How do you get people to talk about it if you're not sure how to approach it? So this slide for me is a little cheat slide. I give it to business, I give it to test managers, I give it to business delivery people. I said, these are your trigger points and your conversation starters. Have those type of conversation. Are we ready to go live? Have the conversation. How will our system handle the unexpected? How reliable is our system? Are we willing to, do we have enough bandwidth to absorb those type of risk? Failovers, are we good with that? why is our system so slow? Have we ever asked the question? Maybe everybody knows that the system is slow, but what have we done about it? Does the system meet our performance requirement? Can we handle Cyber Mondays, Black Fridays? Does it perform as well as the previous one from a performance perspective? What is the rate of users abandoning our app? Can we track that? Do we see if we're having returning users, or do we have a very low level of returning users on our platform? And if so, why? Is this a performance related issue? Those type of questions. Can our cloud platform handle our system and stuff like that? People think going to the cloud solves performance issues, but that's not the case. It depends on the type of product that you bought in the cloud. There are products that allow you to have those type of what we call elastic memories and elastic infrastructure, but that comes at a cost. And a lot of people buy the static infrastructure in the cloud. They don't necessarily buy the elastic, or if they buy the elastic, they buy it up to a certain point. So we cannot make an assumption that by going to the cloud, you solve the performance issue as well. So you have to ask a little bit more questions and understand and deep dive into the architecture in your cloud solution. And also, what will happen if our business grows? Does it scale? Will we be able to load more users? Be it an insurance company, a finance company. If you are in an insurance world, are you able to load more advisors on your platform? Are people able to buy more products at the same time? Those are the type of questions you would ask yourself. What happens if you introduce new products? Does this work, or do we have to budget for more infrastructure, or can we test the system and fine-tune it so that it handles load very well? Because remember, performance is not just an infrastructure conversation, it's also the application code. You can fine-tune your code so that it is very effective from a performance perspective as well. Right. So, and the last column there is, what is our overall customer experience? Are we aligned to industry standards? And what is the expectation of our customer? And are we meeting that? So for me, this is definitely a very practical way to introduce the subject in the organization. And it's a nice little reference, one pager that you can use when you're in projects, or you are talking to people that can influence those type of conversation. All right, so that was that on the whys. We're now going to go into the basics of performance testing in a little bit more detail. So first things I would like to position is that we currently hear the buzzword performance engineering, which is great. When we talk about DevOps, we now in that world of everything is an engineering thing. So there's design engineering practice and this engineering. So what's the difference between performance engineering and performance testing, right? So this is how I position it to my stakeholders here. Performance testing is really at the basis is we are trying to simulate putting a system under different production loads, production volumes of data. And we want to see whether the system behave according to our expectation from a response time perspective, from a concurrency perspective. Does it allow, let's say, 50 concurrent users? Does it allow us to click a page under 3 seconds? Those are very specific SLAs, service level agreement, but it's often driven by technical requirements. The performance engineering world is mostly driven from a more business lens, business process optimization, value chain optimization. So it's not just the testing team that is looking at performance, but rather the entire organization. It becomes a culture in the organization they are trying to drive. When it comes to the what, like we said here, it will be a pure testing exercise, versus in the performance engineering, we look at everything end to end, from the way we address architecture, the way we address requirements, the way we address production, monitoring, and all of that stuff. So it's the full life cycle. And you will notice nowadays, performance testers are also doing a lot of performance engineering. They champion a lot of those themes, but just at its heart, this is the distinction to make it clear. So performance testing is a distinct test process, whereas performance engineering will be an ongoing process across the whole life cycle. And in the performance testing world, a lot of times it's performance engineers and testers, whereas in the performance engineering, we want architects, designers, developers, operation people, all kinds of roles will be doing their part in the performance engineering conversation. And as a performance tester, I would say a lot of time I find myself driving performance engineering because I want to motivate and champion that all these things are happening and drive accountability with all the different parties in the organization. So that also happens, right? So, but that's just a little bit on the basics of what is performance testing. The criteria that drives performance testing is as follows. It's basically your requirements for performance testing, if I can put it in another word. So it's robustness of a system, its usability of a system, functionality of a system. A lot of people don't realize that a system can also be deemed as not functioning properly because it's too slow. So it's not able to do the normal function and business process that it's supposed to do. So functionality will be another requirements driving performance. Capacity, security. Security is a big one. Where, how does it fit into security? It's to do with, like I told you about the cyber attack, denial of service attacks, where you have thousands, 10,000, millions of bots trying to log in at the same time on your system. And it's that concurrency on your system. Maybe your system is not geared to allow over 100 users to log in at once or 100 users to register at once. So bots can try and simulate those type of attacks. It's called denial of service attacks. So that's where when you run performance tests, you are also by default driving the security of your system. And also by doing disaster recovery, you're also checking the security and the safety of your system. So that's that criteria. Availability, we talked about it earlier. It's about being able to access the system globally at any point in time, and also making sure that the system doesn't shut down. So that mean time to failure, there's a metrical mean time to failure and mean time to recovery. We want the system to be available, let's say 95% of the time. It shouldn't have a big margin of being down, and certain systems cannot even afford to be down at all. And all of that needs to be factored in. Interoperability of system, that's where we are saying if a system hops from what platform to the next. An example of that would be in the South African context. If you are applying for a car loan on one of the banking system, and the banking system need to do a credit check with TransUnion, which is our credit bureau, that is an integration that needs to happen and hop to that other system. What we find, when I've done performance testing, I've found that hop may take 20 to 30 seconds because it wasn't coded properly, it wasn't properly developed or catered for. So those type of interoperability really matters as well. And then last but not least is the scalability of a system. So those are the what of performance testing, what drives performance testing. When do we want to do performance testing? In a DevOps world, in the current world that we live in, we want to drive performance testing end to end. So we want to check the design of the solution. That includes the architecture and asking questions. So we call that static testing. So we want to do some static reviews of documents up front, checking that whether they miss certain performance requirements or they miss something in the technical specification document or the architecture. Check the source code. That's where you would use tools like SonarQube and other tools to check the quality of your code, whether the library factored in good coding practices that doesn't introduce performance issues. Check the build. So that's where you're now testing the runtime system. The system is live in an environment, and you can test the system to simulate users logging in the system or using your system. That is that part. Checking every deployment. So that's where we say every time you release new changes, you want to make sure that you retest the system. And also in production, you may do some control testing. Some of you would have heard about chaos testing, using tools like Chaos Monkey and stuff like that. That is also a world that we live in, that we cater for control testing as well. So that's the when we want to run performance testing, and that's the type of picture. So you've got your different your SDLC, your software development lifecycle, and performance as a science is fundamentally broken into the testing component and then the monitoring component. So one should work together. I find it to be less effective if you don't have a strong monitoring base in driving your testing, because whatever you test, you want to also correlate the information to infrastructure stats. A very simple example of this would be, I ran my test at 9 a.m. and it went through a simple process of a car loan application, and I simulated 50 users trying to do a car loan on a system. Whilst my test ran, I want to make sure that I had monitoring in place to monitor the database, the web servers, the load balancers, the API portal, whichever, all the key parts that supports this process. You want to have the monitors running during that same timeline that you run your test. When you finish your test, you stop the monitoring, and then you will compare during the run at this time, there was this amount of users logging in and what was happening on the infrastructure. So you want to bring those views together for you to have a really good holistic view. And that's a very fundamental basis as well of performance testing. I find sometimes a lot of performance testers go out there, they run their script, they just report on response time of a system. For me, that is half-baked. That is not the intent. That is one level. And I agree, it's good to start somewhere. But the ultimate level is where you are now bringing data from a monitoring perspective and bringing them together and getting better observation and better understanding the bottlenecks better, if I can put it that way. And that's also how you gain the trust of the server administrator, you gain the trust of the developer. They can see that you've gone the full route and you've brought the facts and it's foolproof, and there's no denying or rejecting what you're saying, basically. So that's the when and the how. So now let's look at the how. How do we do performance testing? I've given you some example already, but just to put it in writing, you would do manual inspections of doc, of policies and processes, look at architectural design. So that's your manual inspection and reviews. That's one aspect of your job as a performance tester or performance engineer. Second thing you would do is work with the designer. So when they design the software, you want to make sure that they're doing some use case modeling, threat modeling. So a bit of what if scenarios for performance needs to be built in and then catered for in the solution that you will develop at a later stage, right? And when the code is now being developed, you want to do that code review. As a performance tester, I have been in a situation where I ran a test and sat down with the performance test the developer to look at their code, because a lot of times I happen to come from a development background. Sometimes the developer will push back. So you will sit with the developer and you can prove to them, here's the code that's going in an endless loop. Hence why the system is breaking under load, under stress, it's breaking. And that is what we call under that code review. But you're not always expected as a performance tester to do that. It depends on your skill set, but it is recommended that you drive that and you champion that they are driving the right coding practice and things like that. And the bulk of your time will be spent in the dynamic. So that's the runtime environment where you run your test. And that's where you run different test scenarios, different monitoring strategies, and you analyze the result and you run test a few times, different types of load, different types of stress, and you see and you observe those results and report on it. So what I'm explaining to you, this is a little bit of the typical performance world. You will start with some core basics. You will have your requirements, align with business on their expectation, have a strategy in place to detect and diagnose and have the people with the skill set. Then I spoke about the benefits already. But then when it comes to the world of performance tests, these are the types of performance test scenarios that you would do. Each of them have a different objective. Those scenarios you will select based on the objective of your test. You have baseline test, isolation, load, soak, scalability, volume. All of them have different intent, and it will really differ according to the way that you build the scenario. So a very simple example would be, to give you a very basic example, it will be a soak test will be something that you run and you let it run for 24 hours. You just leave the system to run with a small load, but you let it run constantly for 20 to 24 hours and see how it runs. So that would be a form of soak test. A spike test is where you're running a test with 20 users and then you decide to spike it to 200 and see how the system runs, how the system reacts when it's spiked. That will be what we call a stress test as well. That's putting the system under stress. So all of these you learn the differences between each of them, and according to the requirement. Let's say a lot of times business asks you to come just to do concurrency. So then concurrency is just to make sure that your system can increase the amount of concurrent users on the system over time, from 5 to 10 to 15 to 20. So those are the different types of scenarios that you can have. And obviously the monitoring layer, there's different types of monitoring as well. So this is really just a position. I'm not going to go in deep of each of the type. We don't have enough time for that. That will be a whole day training. But really it's just to set the world of performance and what it looks like. And some of the tools are listed there, from Apache, which is an open source tool, to Load UI, which is more on the API layer, to the likes of OpenText. Now it used to be called Microfocus, but it's OpenText, to Blaze Meter, which is also a very, very nice tool, to Eggplant.io. And then some of the popular enterprise tools for monitoring is the likes of AppDynamics and Dynatrace and the likes. So there's lots of tools out there. It's highly recommended that you go and check it out and see what works for your organization based on your budget. Right. So that was it with regards to understanding the basics. I hope that set a nice scene for all of you on performance testing and the why, the when, the what. The next couple of slides is really just to show you how do you introduce this in your organization. So how do you build that practical roadmap? I like to start that by first talking about common challenges you will experience when you try and introduce performance. And I think it's very valid because these will be your immediate battles that you will have to fight. One of them is obviously the one where business is having this habit of just fixing performance issues by just throwing money at the problem in the form of buying infrastructure. The problem with that is obviously over time, it's a lot of money that you're wasting. And then managing your infrastructure landscape over time becomes a problem because the maintenance cost of infrastructure also then becomes a compounded cost over time. That's something for you to be aware of, and you need to know how to address that. NFRs are missed. So most projects to this day do not have performance requirements and security requirements listed upfront. The focus is on functionality, and they do not think about the performance and security, or they accept the risk to go live without it. Like I've hopefully explained today, your functionality can be impacted by performance issues. I worked at a customer that focused on functionality, an insurance company, and that company failed to even pass a 5-user test. They couldn't even have 5 concurrent users where the system will react under 3 seconds. And they just didn't want to have that conversation because obviously they missed the boat there. And it's a real thing. So we should be talking about it in business meeting, in project meetings. We should be talking about it upfront. It's often seen as complex and costly, and test leadership will shy away from this because of the skills gap as well. There's a skills gap in the market. When you do have the skills, performance testers find that there's not enough job for them in the SA market. Most of my performance testing colleagues left the South African market. They are in New Zealand, in UK. It's a really tough one. Either the test leadership are not employing testers and then the testers leave and then there's a skill gap in the market. So it's a bit of an interesting conversation there. But the point is we should drive it. We shouldn't shy away from this. We should, especially in the DevOps world that we live in, it's no longer an option to look at performance, it has to be a non-negotiable. Third-party liabilities. If you're buying software from other companies, you have to always make sure that they do allow you to do performance testing. A good example of that will be software in the cloud, AWS. You do have T's and C's, terms and conditions as to how far you can do performance testing, right? So that's something to consider. And then accuracy of analysis. A lot of times people fail to prove the value of doing performance testing because of the lack of analysis. I showed you on that previous slide how a lot of times people just run the test and then they just give the report in terms of response time. They do not map it to servers. They do not really prove the value of the science. By missing that very important element of monitoring, you lose the value of what you're trying to achieve. People think it's just a response time thing and they can bypass that. So accuracy of analysis is another big challenge that you will see in organization. All right, so how do you start your roadmap? So there's a strategic roadmap. There's also an operational roadmap that I always talk about. So in this slide, I just shared the strategic and a little bit of the practical, the operational roadmap. So from a strategic standpoint, we need to come from a mindset of performance avoidance to performance resilience. How do we build in resilience upfront from day one? We need buy-in, enterprise buy-in to performance engineering. I think that's the better conversation to have, not just performance testing, but rather performance engineering as part of their identity. Driving a maturity roadmap that introduce performance testing. Relook at your software delivery strategy and your test strategy, and then debunk performance through education. Drive the conversation, explain to people how does it look like operationally, practically. So that's for me very important. And then also drive the decentralization of ownership of performance. If everybody does their part for performance, we will be in a much better shape when it comes to that subject. So the operational points, some of the points are as follows. So to have a maturity roadmap, I always talk about this. I drew this little picture for my customers to explain to them that most of the time when it comes to performance issues, you are in firefighting mode. You come to, you talk to a consulting company after a performance issue has happened. A good example would be a telecommunication organization that had a Black Friday sale, and they were selling phones. And for some reason, their billing system broke under the performance load, and the phone were getting sold for half the price. And they lost millions by that. So after that incident, they came to ask for performance testing to help them fix that problem. So it's a very reactive approach to performance, and people must try and get all the way up that ladder to a more business optimizing where they are driving good architecture conversation that factors in performance. But that's a picture, just a side note on that. But operationally, what does it mean? It means driving a community of practice, all the right people in the team to make sure that across the software lifecycle, we are driving the right conversation and the right quick wins. Identifying your SLAs, your core performance metrics that needs to be part of a strategy. Review your IT inventory and prioritize applications that should be performance tested. If you are going to start the journey, practically you need to start by a prioritization list and application that you believe need to be performance tested to begin with, and then you prove value through that, and then you expand it to the wider organization. And enforce performance quality gates in project sign-off. A lot of time as part of project sign-off, we don't have those type of quality gates. So at some of my customers, I drive those type of conversation as well and ask for that to be a non-negotiable. The other practical part is to leverage your existing test discipline. If you're short on money, you're not in a position right now, you don't have the budget, I always say you can leverage your existing testing discipline. It's not, performance testing doesn't mean that it's only highly skilled performance testers that can run this. Test automators can run performance testing. Manual testers can run performance testing. When you're running a manual test and you see the system is slow, you can log a performance defect. And a lot of times they don't log the defect because they think it's not in the scope of work. And I believe we need to debunk that and say, hey, you are testing. If you pick up a performance issue, raise it. If it will be rejected, that's fine, but at least raise it. So I believe we should have a checklist of test scenarios that we talk to functional testers, automation testers, and see how they can help. Like automation scripts can be used as a first pass for performance testing as well. The testing with a one user test, and they could put a timer in their script to start and end of every transaction. And running a test automation script, you could do it's simulating one user, but you are getting metrics for different transactions and how long it takes. So it is a good start, and you are leveraging existing disciplines. If you don't have money to buy heavy-handed tools, heavy enterprise tools, you could train your testers using JMeter tools. The training is available on YouTube, on Udemy. There are freely available training. I mean, people like me offers training on JMeter as well. But the point is, we can start small. Even if you use a tool like Ready API, and you see there's a part of that tool that allows you to do load testing, you can start there and do something instead of leaving it to be completely blank slate. And set a lot of awareness workshops. So I'm a big believer of driving the awareness around performance and getting people to buy into this and be practical about it. What are all your constraints? How do you work around your constraint in your current context and make it work? So that's another very practical type of idea. And the other type of practical ideas is to bring in performance testing tools to drive automation of performance testing across the board. This is a picture of how you could ideally now have smoke performance tests run nightly, get to that world where you run performance tests at an API level. This is way more easy to drive adoption. And you can even get your developers involved, giving them some tools that they do unit testing for performance. So there's a lot of practical things that one can do at an operational level to get this thing going, to get the practice going for performance engineering and performance testing. And those slides really is just to prove that point and showcase how there are small things that we can do to start somewhere and get that growing over time. So where do we aim for success is get your early adopters, talk to people that are willing to drive the subject, start small with basic roadmap. The picture that I'm showing always have to factor in people, process, technology. So as we see on the slide, automation is not the silver bullet. I always have to remind people. An example of this statement here is, it's pointless to do performance testing if the project governance doesn't cater for a sign-off for performance. So you may fail your performance test over and over again, but everybody ignores it or nobody cares. So process and people matter as well. They need to understand the value of what you're doing, and then the testing makes sense. So that's that. And obviously context matters. That's the short statement there. We live in a world where we have to do everything that is fit for purpose. There is no such thing as a blueprint that will suddenly work across the board. We may start with a base blueprint, and then that needs to be customized based on the context and make it fit for the customer. And that's really it from my side. Thank you so much for your time. If you want to learn more about the subject, you're very welcome to contact me or contact the organization, and we can take it, we can discuss more about the subject. Thank you very much for your time.
Leela, thank you so much. Very, very interesting, not an area of expertise of mine, but certainly one I'm very interested in learning about. We do have a couple of questions on the chat thus far, and maybe people will think of a few more whilst we're chatting. May I pose them to you?
Please, I'd appreciate that.
Thank you. So the first one came from Srihari. I hope I'm pronouncing that correctly. And the question is it possible to do performance testing manually without using any tools?
Okay, so my short answer is it's not ideal, but the answer for me is yes, you can. It is not the true science of performance testing, but I keep repeating that example. I worked at an insurance company where the performance testing was failing with 1 user and 5 user. So if you are in a testing, they had 200 testers on the floor running manual tests. They were all running tests at the same time in the test environment, and they all complained about the performance of the system. By default, they were doing performance testing at a small scale, but 1 user, 5 user. And for me, they were not using tools. They were just logging through the system and checking things. And they were a team of 5, and they were all noticing that the system is slow. Aren't you testing performance by default by doing that? Are you not already picking up that there's a performance issue? The challenge with that is you don't have the stats. So you would need to supplement it with stats. So if you could have like an administrator to check how's the system performing in your environment, that would help. But you can definitely indicate that there's a need for a deep dive in a performance subject by doing manual testing. So I believe the answer is, it's not a complete yes, but I believe it's got value in taking account what manual testers are seeing, what functional testers are seeing on the ground when they're testing a system. By default, for me, they are running manual performance testing. And that's my answer.
Thank you, Leela. I think using a South African expression, that's a kind of a yeah and yeah, isn't it? It's sort of a yes, no, but more yes than no. Thank you for that. Appreciate that. And then Riddick, again, I apologize if I'm not pronouncing correctly, has asked the question, which of the tools you listed, and I think this is in the slide that you're sharing with us at the moment, Leela, which of the tools you listed permits one to monitor different components simultaneously? And the examples given are databases, business layers, etc. So monitor them simultaneously during a performance test. Which of those tools? Sorry.
Thank you. So I'll start with not having tools. So I have worked with customers that refuse to spend money on tools. So if they don't want to spend money on tools, I will use Perfmon for Windows-based system. So you default to basic tools like your Perfmon, and then I will go to all the administrators and tell them, you are a server administrator. If you're running Oracle, by default, Oracle gave you a performance tool for your server. Can you please run a cron job or run a file from this time to this time that monitors performance for this server? And I will go to the database person and ask the same thing. They all know, they are experts at monitoring their database and their servers, and they run performance checks all the time on their servers. So they have their own little tool. So a lot of times I find that if you're on an IBM stack, server IBM stack, or Oracle IBM stack, Oracle server stack, or any of the other AWS stack, or any of those big companies, they come with their own little monitoring tool for the server administrator. So I ask the server administrator to then send me those stats, and then I manually bring them together. So that's me living in a world where I don't have a end-to-end performance monitoring tool. And I've done that many times. I've even gone down the route where in a queue environment, I will ask access to those server environments, and then I will run the code. There are specific code commands that you can run on the server and get the stats loaded into a file. So it's very basic commands. It's like your Perfmon for Windows, but you've got one for Linux system and Unix system. They all have specific commands that you can run in a command line and get the data running. And that's if you're crazy like me and you get very technical. Otherwise, you get the server administrator to help you. Alternatively, now, if you have a tool, these are the sample tools like AppDynamics, Dynatrace. These tools are end-to-end, and there's many more tools on the market. If you Google performance monitoring tool or business continuity tools, there are lots of tools. All the big companies like I just mentioned, IBM, OpenText, Oracle, Cisco, they all have big tools that they sell commercially that allows you to monitor things. The ones I listed is the one that does everything. Dynatrace and AppDynamics are the ones that are very, very expensive, but they monitor all the levels, all the components, everything. That was a long answer.
No, that's great. Thanks, Leela. Then we have a question from Nerato, who asks, is there an industry standard for a web-based site or app in terms of response times?
Yes. Response time for web-based system is it has to be under 3 seconds, and then for mobile app, it should be under 1 second.
Thank you. I think there's another one. Oh, someone's asking, will the presentation slides be available? If I'm not mistaken, Leela, you have said that we'll be able to edit this recording and put it up on the YouTube channel. Am I right?
Yes, absolutely. They're very welcome to refer to that.
So
If you
for
want,
the people who are
if you want
attending,
more information, I'll put my email address. You're very welcome to contact me, and I can answer more questions as well. I'll just put my email address in the chat.
Oh, you're a star. Thank you, Leela.